In the history of World War II aviation, there were two outsiders. Two machines born from some of the most reckless engineering gambles ever made. The first was nicknamed by American pilots the Iron Dog. It was shunned, seen as a death sentence for anyone who climbed into its cockpit. Rejected by the very people who built it. The other became such a nightmare for the Royal Air Force that the British planned an outright theft from France just to understand one thing. Why was it so dominant? Forget polished legends like the Mustang or the Spitfire. Today is about bare metal and raw mechanics. America's Bell P-39, or Airacobra, and Germany's Focke-Wulf 190, the Würger. In 1941, the Royal Air Force received its first batch of P-39s. They tested them, then packed them up and sent them back, or pushed them east to the Soviet Union. Why? Because the engine struggled at altitude. Because the strange car-style door felt wrong in combat. And because of a rumor that the spinning drive shaft beneath the pilot's legs would crush them in a crash. Here is the fact that changes everything. The American-built aircraft that destroyed more German planes than any other in history was not the P-51 Mustang. It was the Iron, or Dog. The P-39, more than 4,700 were sent to the Soviet Union. In Soviet hands, it was no scrap heap relic. It was Kobrushka, the little cobra. One man alone, Alexander Pokrishkin, used the aircraft discarded by the Americans to shoot down nearly 50 German planes. So why did Western junk become Eastern treasure? On the other side of the front line, the Focke-Wulf 190 needed no defense. Its name said enough. The Butcher Bird. When the FW-190 appeared in 1941, it hit the Royal Air Force like a slap to the face. It was faster. It rolled harder. Its firepower eclipsed anything the Allies had at the time. Against the Spitfire FA, the imbalance was brutal. Kurt Tank, its designer, never wanted a fragile racer. He built a cavalry workhorse. Rough, durable, unforgiving. More than 20,000 were built. In the final days of the Reich, it became the shattered backbone of the Luftwaffe. Notes. Source. Production numbers. Today, we dissect two of the most brutally practical war machines of World War II. We will see how placing an engine behind the pilot created a flying cannon, and at the same time, a flying coffin. And how a mechanical brain built in 1941 freed German pilots from engine management and let them focus on killing more efficiently. Welcome to the confrontation between Broken Wings and the Butcher Bird. Twio. To understand how strange the P-39 really was, look at this. This is not an aircraft machine gun. This is the Oldsmobile T9, a 37mm cannon. It weighs 200 pounds, about 90 kilograms, and stretches nearly 90 inches, more than 2 meters long. Bell Aircraft had no choice but to design the airplane around this weapon. To mount a cannon more than 2 meters long in the nose and keep it accurate, there was no space left for an engine. The solution was drastic. The heavy Allison V-12 was pushed behind the pilot, placed directly at the aircraft's center of gravity. That decision created a mechanical nightmare. A drive shaft nearly 10 feet long. It ran beneath the cockpit floor, belinking the rear-mounted engine to a separate reduction gearbox in the nose that turned the propeller. Picture yourself sitting there. A steel shaft spinning between your legs at engine speeds reaching 3,000 revolutions per minute. It was shielded, yes, But the fear of that shaft snapping in combat and crushing the pilot's legs was a real psychological burden for American pilots. With the drive shaft and gearbox filling the nose, there was no space for a sliding canopy. The P-39 used side-opening car doors. They were convenient while taxiing, with the window rolled down. In the air, they became a tight and deadly trap. In an emergency escape, if the door was not jettisoned perfectly, the high-speed airflow would slam the pilot straight into the tail. Soviet ace Nikolai Iskrin broke both legs this way. Boris Glinka suffered severe injuries, all from a lethal design flaw. Now to Germany. Kurt Tank faced the opposite problem. He wanted the BMW 801 radial engine, air-cooled and as tough as a workhorse. Its displacement was enormous, 41.8 liters. Its diameter was just as large, creating serious aerodynamic drag. Tank answered with an aerodynamic masterpiece. He installed a 12-blade cooling fan that spun at 3.14 times the speed of the main propeller. But the real brilliance lay in the oil cooler ring. Instead of bulky external radiators like the Spitfires, Tank hid the oil cooler inside the engine cowling. High-speed airflow passing through the annular gap created a vacuum effect, pulling hot air out of the engine with almost no added drag. This was the FW-190's hidden weapon at high speed. Push rods. British fighters relied on cables that stretched under load. The WWII-190 used rigid push rods with bearings, keeping control forces precise and predictable. The result was clear. At 400 miles per hour, a FW-190 pilot could still roll the aircraft smoothly. Stick forces stayed between 8 and 12 pounds. A Bf-109 pilot needed nearly 20 pounds to do the same thing. One aircraft relied on a 3-meter drive shaft to carry a heavy cannon into combat. The other used forced cooling and rigid push rods to tame aerodynamics at high speed. Both were engineering monsters. And in both, a single mistake at the controls could end in disaster. Notes. End of Part 2. The strange design itself did not kill pilots. Physics did. Let us start with the Bell P-39 and a gamble called center of gravity. When you pull the trigger, the 37mm cannon and machine guns erupt. But something else happens at the same time. Weight is being thrown away from the nose. Once the ammunition is gone, the nose becomes light. The center of gravity no longer sits over the wing. It moves rearward, toward the heavy engine behind you. Think about throwing a hammer. When the heavy head goes first, the flight is stable. An empty P-39 behaves like a hammer thrown backward. The light end leads. The heavy end follows. And the aircraft is eager to swap ends. The result is a nightmare called the flat spin. If the pilot pulls too hard after the ammunition is gone, the aircraft doesn't stall and drop its nose. It spreads out flat and spins like a dry leaf in the wind. Soviet Air Force research reports were blunt. Once the aircraft entered this state, the pilot had half a second to react. Any delay locked the aircraft into the flat spin. No airflow reached the tail controls. Recovery was impossible. Many American and Soviet pilots died without ever being hit by enemy fire. This physical trap claimed them instead. The P-39 punished carelessness with sudden death. While the P-39 struggled with stability, Germany faced a different physics problem. How do you turn when you are moving as fast as a bullet? Most fighters of the era, like the Spitfire and P-40, they used cables to link the controls to the wings. Above 400 miles per hour, air loads on the control surfaces became enormous. The cables stretched. The control stick felt like it was set in concrete. Kurt Tank refused to accept that. The FW-190 received rigid push rods and bearings. They did not stretch. At any speed, a movement of the wrist was enough to make the aircraft respond instantly. The outcome was absolute dominance in agility. British and American test charts all pointed to the same unsettling conclusion. This was the number that kept the Allies awake at night. 100, each 62 degrees per second. At a combat speed of 250 miles per hour, the FW-190 rolled 1.5 times faster than the P-40 and twice as fast as most of its opponents. This created the flick and dive tactic. When a Spitfire closed in from behind, the German pilot made a brief input on the stick. The FW-190 snapped inverted and dove away. The British pilot, fighting a frozen control stick, could only watch it vanish. The difference came down to muscle. At high speed, a Bf-109 pilot needed more than 20 pounds of force, often using both arms. The FW, at 190, required less than 10. One aircraft kills you the moment you lose respect for its center of gravity. Another lets you maneuver at speeds where others are already paralyzed. That is the physics of death. In 1941, air combat was not just about shooting. It was a constant struggle with engine management. Allied pilots had to manually juggle fuel mixture, propeller pitch, and cooling. One small mistake, and the engine overheated or quit. FW-190 pilots did not face that burden. Hidden beneath the cowling was a technological secret, decades ahead of its time. The Kommandogerät, the command device. In practice, it was a mechanical hydraulic computer. It processed around 30 different inputs and outputs. Move the throttle, and the system calculated fuel mixture, propeller angle, ignition timing, and even shifted the supercharger automatically. Remember what it was controlling. The BMW 801, 41.8 liters, 14 cylinders, 1,600 horsepower. Taming that monster with a single lever was an engineering marvel of its era. The combat advantage was absolute. While the British pilot looked down, fighting the controls to gain altitude, the German pilot stayed focused. He was not acting as a mechanic. He was hunting. His eyes stayed on the enemy, not on engine gauges. Leaving the German flying computer behind, we returned to American brutality in the P-39. Here, there was no automation. Only noise, vibration, and effort. You sat directly above a driveshaft 10 feet long. It linked the V12 engine behind you to the gearbox in the nose. At takeoff, it spun at nearly 3,000 revolutions per minute right beneath your body. American pilots called the experience disconcerting. The gearbox whining in front, the engine roaring behind, and the vibration of the shaft beneath their feet created an intensely stressful workspace. The cockpit was extremely cramped. Yet here lies the paradox. The P-39 had one lethal advantage: visibility. With the engine mounted behind, the nose was surprisingly slim. Soviet pilot Nikolai Golodnikov praised it. The visibility was excellent. The instrument panel was very convenient. It was the best fighter I ever flew. One aircraft represented the peak of automation, freeing the pilot from mechanical chores. The other was a rough compromise, forcing the pilot to adapt to the machine. War, however, does not reward comfort. The FW-19O's refinement let German pilots fight longer. The P-39's harshness found a pilots who adapted perfectly to it on a very different battlefield. Why did a failure in the West become a king in the East? The answer lies in altitude. War in Western Europe was fought in the stratosphere. War in Russia was fought at treetop height. The United States made a critical mistake when the P-39's turbocharger was removed. The consequence was immediate. Above 15,000 feet, the Allison engine began to choke. There, the aircraft became easy prey for the Luftwaffe. American pilots called it the Iron Dog and tried to trade it for the P-38 or the P-47. The Soviets did not care about 15,000 feet. They needed to protect tanks. At low altitude, where the air was dense, the P-39 was faster than both the Bf-109 and the FW-190. It had reliable radios, a warm cockpit, and most important of all, it could absorb punishment. Alexander Pokrishkin turned it into a lethal weapon with the tactic known as the Cuban stairs. Instead of outdated line abreast formations, he stacked pairs of fighters at different heights. The lowest group acted as bait. The higher groups waited above, ready to dive on anyone who took it. One myth must be discarded. The P-39 was not a tank killer. The United States supplied the Soviet Union only with high-explosive shells. No armor-piercing ammunition was provided for the 37mm cannon. The Soviets used the 37mm cannon to tear apart bombers, not tanks. Pokrishkin even rewired the firing system so the cannon and machine guns fired together. One press of the trigger unleashed a storm of fire that could erase any Ju-87 from the sky. Meanwhile, in the West, the FW-190 faced annihilation from thousands of machine guns aboard the B-17 flying fortresses. To survive, the aircraft had to evolve into the Sturmbach. The battering ram? The A8/R2 variant carried thick 30mm armored glass and steel plating around the cockpit. It was heavy. It was slow. It required escort by Bf-109S. But it carried a supreme weapon, the Mk-108 30mm cannon. The tactic was brutal. Gefechtsverband. German pilots attacked from directly behind, driving straight into the defensive fire. They were ordered not to fire until they could see the whites of the enemy's eyes. Why get that close? Because the short-barreled 30mm cannon had a steep ballistic arc. But its power was devastating. On average, just 3 to 4 mine-shell hits could rip the wing off a massive B-17. But these pilots wore white crescent markings around their eyes, a symbol of their willingness to fight at point-blank range. The FW-190 had transformed from an agile fighter into a flying tank, trading lives in the skies over Germany. The P-39 found glory flying low in support of the Red Army. The FW-190 found destruction wearing heavy armor against flying fortresses. Two destinies, shaped by military doctrine. One was a pioneer of ergonomics. The other paid the price for brutal design compromise. Yet both teach the same hard lesson. There are no bad aircraft. Only aircraft sent to the wrong battlefield. The Focke-Wulf 190 stood at the peak of German engineering. With the Kommandogerät, a mechanical computer that governed every breath of the engine, it reached decades ahead of its time in automation. Kurt Tank did not build a toy. He built a workhorse. Versatile. Durable. Relentless. From air superiority fighter to armored bomber killer, the FW-190 remained a nightmare for the Allies until the final days of the war. The P-39 Airacobra tells a different story. One pilot's junk became another pilot's treasure. Rejected in the West for lacking a turbocharger. Branded the Iron Dog for its unforgiving handling. Yes, it carried a lethal flaw. A shifting center of gravity that could trigger deadly flat spins. Yet the aircraft still found the right hands. In the hands of fearless Soviet pilots like Pokrishkin, guided by disciplined tactics, the weaknesses of the P-39 faded behind its destructive firepower. It became a winning weapon, shooting down on more German aircraft than any other American fighter type in history. And you? If you had to fly into the furnace of World War II, would you choose the German mechanical computer, freeing your hands to fire? Or the American flying cannon, feeling every vibration of the driveshaft beneath your feet? Leave your thoughts in the comments below. Like and subscribe so you do not miss our next deep technical analysis. Thank you for watching.